Okay, welcome everybody here to physics. We're going to talk today about the if I do, I die formula and its sign convention, and then we'll end up with a little bit of calculation sample problems too. So just so you know what we're talking about here, this F is the distance that the focal point is away from the mirror along the principal axis. This D sub O is the distance that the object is away from the mirror measured on the focal or on the principal axis. And this is the distance that the image, and their relationship here is this nature: the inverse of the 2 is equal to the inverse of the 1. And I'm going to show you what the sign convention is. I came up with this little thing to help remember that if we have something that's real, the number then will always be a positive number. And if it's fake, the number will always be a negative number. Okay, so if we're talking about the focus first, we have two types of mirrors. We have a mirror that is called concave, but it's a converging mirror because it makes the rays converge upon a point. And then this is a diverging mirror, or a convex mirror. And this actually spreads the energy of the light coming into it. So we'll kind of look at this. This here would be a focal, and if we would take the radius of this circle, if the radius was here, this focal point would be at half of the radius, and this is for a spherical mirror. Okay, and on this mirror, a lot of times you see the hash marks here to show the sides that don't actually reflect. But this mirror here then doesn't have a focal out here, but yet it has a focal in here. But I call this the focal point because it's really a fake focal point because there's no convergence of energy at that point. So if we get far enough from a light source, we'll see that when we have rays coming in parallel to one another, due to the principal law of reflection, the incoming ray will reflect and go right through the focal. The principal law of reflection, I didn't draw my tangent to that point very well. But the principal law of reflection says that the incoming ray angle is equal to the reflected ray as measured from the normal. So these angles here should be equal to each other. And that normal would be on a tangent to the circle. As you can see, my geometry is not very good at this point. But the principal law of reflection says that the incident ray angle and the reflection ray angle are equal to each other according to the normal of the surface. So what happens here then is we get all of our rays bouncing through this focus from no matter what side they come or no matter where they hit. And this happens here to center all the energy at that focus. And that's why they call this a converging mirror, because it's converging all the parallel rays coming in. So like a satellite dish has the dish here, and then they have a receiver box out in front of that, and that receiver box is at the focal. And so all these less powerful electromagnetic waves coming in then get bounced back, and the addition of their power then happens at the focus. So sign convention for the focus of a converging mirror, since it's a real focus, would be positive. So for this number, it would be a positive number for a converging mirror. Now if we look at the focus of a diverging mirror, what happens in this piece, same law of reflection. So if I had a proper tangent here to that curve and a proper normal, we would notice that these two angles are equal to each other. the incident ray is equal to the reflected ray. And that will happen at all points. As you can see, these two rays here are actually spreading further away from each other. They're diverging. So they never will come to a true focus. Excuse me. Just like this one, none of these actually converge and add none of the ray is focused. None of the power and the energy is focused at a point. So this is actually a fake focus back here. And so if we look at the convention, if it's fake, then the number is going to be a negative. So if we were to do math with that mirror, this focus here would be a negative number at a distance from the mirror. Now we have to talk about the convention and what it has to do with the images and the objects. Okay? So this sign convention for the objects is still the same. We have our converging lens, we have a focus, a converging mirror. If this is where the object is, that's going to be shining its reflected light into the mirror. For our purposes, the object is always positive. So this distance number that the object is away from the mirror will always be positive in all of our ray tracings. Now if we go through and we trace this ray, as shown on the last video, we will see that this here is the point that we will get our image. So this is the object, this is the image. And these distances here, these distances of the object and the image, they're always measured from this point to this point. Okay? So if we look at the distance that this image is away from the mirror, I can tell you that this is a positive number. Now, the reason why I'm telling you that is because I know from looking at this that it's a real image. Okay? And since it's a real image, it's a positive number. Now, how do I know it's a real image? Well, plain and simple. Every inverted image is real. Okay? And along with this real image being real, it could be focused and placed on a board. So if I had a tag board here, I could see a picture in focus on my tag board. So I can project a real image. Okay? Let's take a look at another instance here. Let's say that I have another converging mirror or concave mirror. Here's my focus. Let's see that my object here is here. I do some quick ray tracing to try to find out where my image will be. And I see that I get these two lines here that will not converge. And if they won't converge, I'm not going to get a real image. So what I have to do in this case is take and what we call back trace the reflected ray. See where that comes from? And at this point here, I know that I have a fake image. And the reason why it's fake is because it's upright. So this distance from the mirror to that image is fake, is going to be a characteristic of a fake object. Therefore, in this case, the distance to the image would be a negative number. Okay. Now there's one more equation that we want to talk about here. And this sign convention is not the fake and real sign convention. This sign convention is different. Although I'm going to tell you about diverging mirror first. Actually, I'm not. So I'm going to tell you about our magnification equals hiho equals negative dido. Okay. So the real is fake, or the real is positive, fake is negative, sign convention still goes for this part. But this part is different. Okay? And so I'll tell you about this one. If I have a converging lens and I have an object here and I do my quick ray tracing and discover that I get an object over here, the sign convention for this is the height for this, if we call this direction a positive number, then the height of the image, or of the object, is a positive number. Now this is kind of like vectors. If the image is on the same side of the principal axis and going in the same direction, we call that height of the image positive. And if that's the case, then we get a positive magnification. If we have a situation like this, and we do a quick ray tracing to find out where our image is, we find our images here. Now, if we call this height a positive number, then because this is on the other side of the principal axis in the opposite direction, we call this a negative number. So this height of the object here would be a positive number, but the height of the image would be a negative number, making our magnification a negative number. The next video will show how to do the math with this sign convention.